Hello everybody, once again welcome back to MRS math class, and this video I have prepared as per the demand of the viewers. That is, the topic name is binomial theorem. Okay students, so bi means everybody we know that is two, and nomial means terms. Okay, so we are going to discuss about two term expansion. Okay students, if you'll see that in the history, that is near about 4th century BC, when Greek mathematician Euclid mentioned about some special case of binomial theorem for exponents. From that day onwards, so many mathematicians research are using this binomial theorem in their research and getting so many nice results up to today also. What is binomial expansion? In elementary algebra, this binomial theorem or binomial expansion means the algebraic expansion of powers of a binomial. Okay students, so let us see what is this binomial theorem, and what are the applications of binomial theorem. That also I will discuss in the last part of this video. And so here you can see a triangle like numbers are there, and what is this triangle actually? The triangle name is Pascal's triangle. This triangle plays an important role in binomial theorem. So I thought, okay, first the basic things I should discuss. Okay, so as you can see, this in Pascal triangle, this triangle looks very beautiful, and the two sides of the triangle are 1, and some numbers are there in the middle part of this triangle. That is, you can see you can see that this term plus this term is getting this term, and when you are adding these two terms, you are getting this term. When you are getting these two terms, you are getting this term. When you are adding these two terms, you are getting this term. When you are adding these two terms, so this way I have prepared this Pascal triangle. For n equal to 0, we are getting this one. For n equal to 1, that means for second row I am getting this one. For n equal to 2, that is third row, we are getting these terms. So both the sides there will be 1, and inside you will form in this way. I have prepared this Pascal triangle only for n equal to 7. You can calculate you can extend it also for more number of rows. Okay, if you understood this Pascal triangle, now let me discuss about the combination. Okay, that is NCR. That means n items taken R at a time, and the order in which these items are chosen does not matter. Okay students, so the formula is n factorial over R factorial into n minus R factorial. Okay students, this is the formula, and this n factorial, if I will ask what is the formula of n factorial, then I hope you know the answer is n into n minus 1 into n minus 2, okay, up to 1. Okay, so how this combination is interlinked with Pascal triangle, let us understand. So if you understood this formula, then you calculate for 2C0. okay, what is 2C1 and what is 2C2? Now you calculate immediately. Okay, so it is 2C0, that is 2 factorial over 0 factorial minus 2 minus 0 factorial, right? So what it will come, that is 2 into 1, correct? So 0 factorial, you should remember, that is not 0. 0 factorial is 1. Okay, so 1 into 2, that is your 2 over 2, that is 1. Okay, similarly, if you will 2C1, if you will calculate 2 factorial over 1 factorial into 2 minus 1 factorial, that is 2 into 1 over 1, right? So you will get 2. Similarly, 2 factorial by 2 factorial into 2 minus 2 factorial, that is your 2 over this 2, and this is 1. So you are getting 1. So now you can see how this is related to this triangle. So if you will see, when n equal to 2, here I have taken n equal to 2, right? So you can see this 1 and we are getting from 2C0, correct? This 2 we are getting by considering 2C1, that is 2, and this one we are getting by considering 2C2, that is 1. So these members of the triangle we are getting from this combination. Okay, similarly, if you will calculate 3C0, that is 1, you will find out What is 3c1? You will get 3. 3c2 you will get 3. Similarly 3c3 if you will calculate, you will get 1. Similarly you can proceed for n equal to 7. So this combination plays an important role here. Okay students. So if you understood up to this, now I will ask some questions, very easy questions. Give me the answer. Slowly we will proceed towards binomial theorem. Okay, that is what is a plus b to the power 0? Quickly, anything to the power 0 is 1. Correct? Now a plus b whole to the power 1. What is the answer? A plus b, right? Now a plus b whole square, what is? Do you know the formula? If you have seen the Odia movie Harapatnaik dialogue, don't remember? That is a square plus b square plus 2ab. Correct. So this formula is a square plus b square plus 2ab, right? Now if I will ask a plus b whole cube, then what I will tell? You know the formula, that is a cube plus 3a square b plus 3ab square, right, plus b cube. Am I correct? So what thing you are marking here? I am expanding these two terms by binomial, right? These two terms in the powers we are increasing, right? So up to this you can get. If I will ask a plus b whole to the power 4, if I will ask a plus b whole to the power 5, then slowly it will be difficult for you to find these values. If I will ask a plus b whole to the power 56 or 100 or 200, then what you will do? So in that case we will use this binomial theorem, okay students, and easily we can find the value. So one thing you can mark here, okay, that is if I'll write the binomial theorem for general case, okay, a plus b whole to the power n. N is any large number belongs to your integer, in that case positive integer, then what you will do in this case, okay. So one thing you can mark here, a plus b whole to the power 0 is 1. So what is the coefficient? When n equal to 0, you are getting the coefficient as 1, okay. And a plus b whole to the power 1, this coefficient is 1, this coefficient is 1, okay. And a plus b whole square, this coefficient is 1, right. Then you should write b square, we will take to the right hand side, okay. Then this 2 you are getting from here and 1 you are getting here, correct. So the coefficients we are calculating, we are getting from this Pascal triangle using this combination, okay. And what you are marking here, that is a, b, then here a is the highest power 2, right. Then here decreasing a power, then increasing b power is increasing by 1, then increasing by 2. So if I will write here also, you can see this coefficients you are getting 1, 3, 3, 1 from here, 1, 3, 3, 1. Then first you will take the highest power of a, first term, right. Then slowly it will decrease. You can see here this is 3, this is 2, this is 1. Here nothing is there, means a to the power 0. But what is happening in case of b? First b to the power nothing is there, means b to the power 0, right. Then b to the power 1, then b to the power 2, then b to the power 3. Slowly it is b power is increasing and slowly the power of a is decreasing. So if you write this a plus b to the power n, so what you will get? So come to this side, that is a plus b whole to the power n. For n we are going to write the formula of binomial theorem, right. So first of all we will complete the coefficients, right. That is first nc0, right, plus you can write nc1, correct, plus some term into nc2, correct, plus up to ncn, right? Correct. Now we are going to write the power of a and b. Okay, so whatever I noticed that first a power it will be maximum, that is n, and slowly it will reduce by 1, right? If this one will be a to the power n, then this one it will be a to the power n minus 1, right? This one it will be a to the power n minus 2, right? Similarly up to here it will be a to the power n minus n, that is a to the power 0, that is 1. So no need to write. Okay, now we will write the power of b. Okay students, that is b to the power 0, that is 1, so no need to write. So here b power it will increase by 1, that is b1, that means b. Here b power is 2, right? And at last b power it will be n. Okay students, so this is the general binomial theorem. Okay, and this one if you will write in summation form, then what you will get. Okay students, so write down a plus b whole to the power n, that one you will get as summation over k equals some k equal to 0, right? And here you will get n c k, right? And a to the power n minus k, b to the power k. So this is the summation form of this binomial theorem. Okay students. Okay, one thing also, that is if you will replace plus b as minus b, then what you will get. Okay, so a plus minus b to the power n, that means you can write as a minus b whole to the power n. That means just we replaced plus b as minus b, and you will expand, what you will get. Okay, same thing you will get, but first it will be plus, then minus, then plus, then minus. That way it will increase. So let me write nc0 a to the power n, then it will be minus. Okay, nc1 a to the power n minus 1 b. Okay, then this one will be plus, right? nc2 a to the power n minus 2 b2. Okay, then this will be minus. Similarly we will write. Okay students, so this is a minus b to the power n. Okay, now we will write in terms of summation, then what we will get. Okay, if I am writing in the summation form, then what you will get, that is k equal to 0 to n, right? Minus 1 to the power k. That means first you will get 0, that means 1. Then 1 if you are getting, then minus 1. If you will put 2, then it will be plus, minus, plus. This way it will proceed, right? And everything will be same, that is nck a to the power n minus k bk. Okay students, this is the final binomial theorem. Okay students, so note down the formula, and this formula we are going to use. That means I am going to discuss about the applications of binomial theorem. Okay students. Okay students, now we will discuss about the application of binomial theorem. Okay, in probability you can say, or abstract algebra, in every field there is a role of binomial theorem. But now I am going to discuss about one application, that is multiple angle identities. Okay students, in complex number, by the help of this binomial theorem in combination with de Moivre's theorem, we are able to calculate the multiple angle identities for sine and cosine functions. Okay students, let us see how we are getting. So first of all we should know what is de Moivre's theorem. Write down de Moivre, okay, es, de Moivre's formula. What is this? Now cos nx plus I sin nx, okay, is equal to cos x plus I sin x whole to the power n. Okay students, this is the de Moivre's formula. Okay, now we are going to expand this term, okay, by binomial theorem. So how we will do? Let us try for by taking n is equal to 2. Okay, then what you will get? Cos x plus I sin x whole to the power 2. Okay, then what you will get? This one it will be cos square x, right? Then this will be your minus sin square x, right? Plus 2i cos x into sin x. Okay. And this one, by using de Moivre's formula, what you will get? This is your cos 2x plus I sin 2x. Okay students, now here we will separate the real part and imaginary part. Okay students, that is cos square x minus sin square x plus I into 2 cos x into sin x. Okay, now if you will compare this left hand side and right hand side, what you will get? You will get cos 2x as cos square x minus sin square x, right? And sin 2x as 2 cos x sin x, right? Or 2 sin x cos x, whatever. So this formula we derived by the help of binomial theorem in combination with de Moivre's theorem. So this way we are using the binomial theorem. This is for n equal to 2. If the same way, if we will proceed for n equal to 3 and 4 and like that, what you will get? Finally you will get cos nx, okay, as in the form of summation I am writing, since cos is even function. So k even, you will get minus 1 to the power k by 2, right? nck cos to the power how much? N minus k x into sin x. Okay. Similarly, for sin x, sin nx, you will get k odd, right? Minus 1 to the power k minus 1 over 2 nck cos n minus k x into sin x. Okay students, this is the general formula for cos nx and sin nx, right? And this thing we got by the help of binomial theorem. Okay students, hope you understood the lecture. Still, if you have any doubt or any query, you can ask me in the comment box. Okay students, thank you.